Now let's look at what happens with the cosine function. You may actually notice that the cosine function looks almost exactly the same as the sine function, except for it just shifted horizontally. So you're going to see the same wave pattern. But you'll notice that at 0, we start up at the max rather than starting at 0 on the y-axis. So here you have your key values for cosine. And again, most of these we've already found together, or you can find using reference angles and things. So this is a good chart just to have a very, again, common cosine values. And I have just the first period graphed. So just like the sine function, the period of the cosine function is also 2 pi. And then what happens is this repeats. So again, you can kind of excuse my graph, but it's going to keep going in both directions like a wave. So it looks really exactly like the sine function, except for its initial starting cycle starts up at the max rather than at 0, but you have that same wave piece. And if you graph it on Desmos, you'll see this as well. So I'm going to skip that part here in the video. You can graph it at home. And again, just to remind you guys, that website, oops, spell it right. That's an M there. That website is Desmos. They also have an app as well. So it's just really helpful, and you can really see the whole cosine function and that it just repeats over and over again. So this is our base cosine function. And just like with the sine function, we can obviously tweak it. So I'm just going to run through 1 or 2 examples here with cosine, because we did quite a lot with sine, and they work very similar. So we have an amplitude. We do have something that affects the period. We do have phase shifts. So you have very similar changes here, but we're going to use really the same strategy as well. So let's go ahead and we're going to look at some examples. All right, so I'm going to jump right into really kind of the full spectrum of changes that we can make. There's actually one more we can do as well, but this is kind of where we ended with sine. So I'm going to jump right in here because we've already done a few examples. So here, A is still your amplitude. The period for cosine is still 2 pi, but if you do have that multiplier on the x, it would be divided out. So you have that same change if it's the cosine. And then you still also have that phase shift. And it's C over B. So whatever this is divided by B. And again, if your C over B is positive, then your shift is to the right. So you're starting to the right of 0. And if your C over B is negative, so what happens is you actually have a plus sign there because you have a negative and a negative, make a positive. You actually start to the left of 0 for your cycle. And again, this is the start of the cycle or period, however you want to think of it. If it's not x equals 0. So if there's no phase shift, you're starting at 0. And we're going to do the same sort of idea here. We're still going to find those 5 key points, and really not much has changed. So I'm going to just kind of skip some writing here. We're going to do the same thing we have been doing. I'm going to find the amplitude. I'm going to find the period. I'm going to find the phase shift here. And then I'm going to graph one period of the function. So our amplitude is the value out front. So it's the absolute value of 1/2, which is just 1/2. So again, what's going to happen here is your maximum y value is going to be 1/2. And your minimum y value is going to be negative 1/2. Our b value is 4. So instead of our period being 2 pi, which is what it normally is for the cosine function, it's going to be 2 pi divided by 4, which is pi over 2. So you're going to see it's going to cycle or oscillate faster. So you're going to run through those cycles much quicker here. There is a phase shift here, right? Because we're adding or subtracting something there. You do want to be a little careful. So here's something to watch out for. Normally we have a subtraction sign. Here we have a plus sign. So what that means is it must be minus a negative pi. So the formula should have a minus sign in it. When it does not, it means that the C value is negative. So our C value here is actually negative pi, and then we're dividing it by 4. So we're going to start our cycle at negative pi over 4 instead of 0. And again, because it's negative, you're going to the left. So you're going to start to the left here. And again, that's something to watch out for whenever you have a phase shift. All right, so we start the cycle at negative pi over 4. And then for adding it, you're still going to take your period over 4. So our period here is pi over 2, and we're dividing that by 4. So I can multiply this by 1/4, and I end up getting pi over 8 as the value that I'm going to be adding each time. So for x2, I take negative pi over 4. I add pi over 8. Now you have to have common denominators here. So this would be negative 2/8 instead. So when I go ahead and add, I get negative pi over 8. Again, we're going to add pi over 8. So my third one will be negative pi over 8 plus pi over 8, which is 0. Add it again. Again, these two are kind of nice. 0 plus pi over 8 is just pi over 8. And then for the last one, pi over 8 plus pi over 8 is 2 pi over 8, which simplifies to pi over 4. So now that I have my key points, I do have to find my y values. All right, so we're starting at negative pi over 4, negative pi over 8, 0, pi over 8, and pi over 4. And I'm going to go ahead and plug those in each time. So I have 1/2 cosine of 4 times negative pi over 4 plus pi. 4 times negative 0. Now, cosine of 0 is 1. So when I multiply that through, I get 1/2 here. And then I'm going to continue on. So 1/2 cosine of 4 times negative pi over 8 plus pi. 1/2 times cosine. Okay, so here I have negative 4 pi over 8, which is negative pi over 2. Negative pi over 2 plus pi is going to be what? Pi over 2. And then cosine of pi over 2 is 0. And 1/2 times 0 is 0. And I'll save us the writing. You guys can figure the rest out at home. It's going to be the same process. When I'm getting to things like cosine 0 and cosine pi over 2, I'm just using my charts that I've already made, right? I know a lot of those key values already. So a lot of times you're simplifying to something you already know. When I plug in 0, we get negative 1/2. When I plug in pi over 8, I get 0. And then when I plug in pi over 4, I get positive 1/2. All right, so here I'm actually starting over here, negative 4, negative pi over 8, 0, pi over 8, pi over 4, etc. And again, I'm going to just keep graphing in blue here. So at my first value, I'm at 1/2. So Why don't we do this as 1/2, 1, negative 1/2, negative 1. So I'm over here at 1/2. At my next one, I'm at 0, and I'm at negative 1/2. I'm at 0, and I'm at 1/2. And just remember, this is a curve. It kind of looks like a line when I'm just doing the points, but you do have a curve there. And that's just one period. So we only had to graph one period for this question. But again, you could extend it. This going to keep going over and over again, etc. And you can find more points by just adding that same value. So we were adding pi over 8 each time. So if you keep adding pi over 8, you can just keep adding the tick marks and follow that same exact pattern for the y values and keep going over and over and over again. All right, so the last example I want to do here is I do want to bring in some vertical shifts. I haven't talked about those. I shouldn't say I've talked about them, but I haven't actually shown you what they look like yet. And I'm going to do both. We're going to do an example with cosine. But I'll show you, it also works for sine the same way. So a vertical shift is when you have something like this. So let's see, you have a sine of bx minus c plus d, or you have cosine. So this right here, this plus d, this is your vertical shift. If d is positive, the whole graph is up d units. And if d is less than 0, so it's like a minus d, the whole graph shifts down d units. And one thing to note is you do vertical shifts really sort of last. So as you're finding your y values, you will end up incorporating that plus or minus d. You don't have to really worry about it in the beginning. It's not going to affect the initial amplitude, the initial period, or phase shift. You will notice at the end is it will affect the final max or min value, because even though the amplitude is still correct, you're going to take that graph and shift it up or shift it down. So you will change your final y values for that. But when you're initially starting off with the amplitude and things like that, it does stay the same in the beginning, but it will affect it at the end. So that's one thing to watch out for. So what happens is, maybe, let's see. So what happens is the max value, the amplitude, and your min value of y would be the d minus the amplitude. So it does affect it at the end, but when you're initially thinking about your amplitude, that part stays the same for the stretching, and then the whole thing shifts up or down. So let's just do one example here with cosine. So here I have 1/2 cosine x minus 1. So, just one thing to note here is your amplitude is still the absolute value of 1/2, which is 1/2. Now, because there's a minus 1, this will not be your final max or min, but you can think about how it's affecting this graph vertically. The period is 2 pi, so really there's no b. So b would actually be 1 in this case. You could always multiply by 1. So there's no b. And there's also no phase shift, right? So c is equal to 0 here. There's no phase shift. So we start the period or start the cycle at x equals 0. But you do have a vertical shift. So notice that your d is equal to -1. So what happens is at the end, the whole graph is going to shift down. So instead of your max and min being at 1/2 and -1/2, it'll actually be at let's see, -1/2 and -1.5, because the whole thing is going to shift down 1 unit at the end. So we'll see that. Now you're still going to find your 5 key points the same way. So my first one is my cycle starts at x equals 0 here because there's no phase shift. And then remember, we add the period over 4. So our period is 2 pi, and divided by 4, we have pi over 2. So our second value is going to be pi over 2. We're going to add pi over 2 again, and we get pi. Pi plus pi over 2. Again, using common denominators here, you'd have 3 pi over 2. And then finally, 3 pi over 2 plus pi over 2 is going to give you 4 pi over 2, which is 2 pi. So we actually have the same spacing as the original cosine function for the period and for those key points. Everything in. So I have 1/2 times cosine of 0 minus 1. Notice that minus 1 is not in parentheses, so it's outside the cosine function. It's not like the phase shift. So this becomes 1/2, and cosine of 0 is 1. 1/2 times 1 is 1/2, minus 1 is -1/2. And then I do 1/2 times cosine of pi over 2 minus 1. Well, cosine of pi over 2 is 0. 1/2 times 0 is 0, and 0 minus 1 is -1. One-half, and then cosine of pi is -1. So 1/2 times -1 is -1/2, minus 1 is going to be -3/2 or -1.5, however you want to think of it. And then I'm going to do the same thing for the last two. So you guys can do these last two. You get -1 here, and you get -1/2. I'm just going to graph one cycle, one period here. I am starting at 0, and then pi over 2, pi, 3 pi over 2, and 2 pi, just going through my usual marks right there. And let's see, our first value is at, I should have -1, -1, and 1/2. So I'm at -1/2. At pi, I'm at -1. Oh wait, hang on. Oh, I'm messing this up. Give me a second. At 0, I'm at -1/2. Sorry, guys. Let's do this in pink instead. At pi over 2, I'm at -1. I'm reading the wrong points. At pi, I'm at -3/2. At 3 pi over 2, I'm at -1. And then at 2 pi, I'm at -1/2. That looks better. So our graph looks like this for one period, and that you can see that main period right here. So the height changed a little bit. You have that amplitude of 1/2, so it did squish a little bit down from 1, but then the whole thing shifted down. So you did have your max and min being affected there because you have that entire shift down.